An atmospheric river can be described as a flowing corridor of water vapor in the atmosphere. They form over the ocean and are pushed along by low altitude winds, and can grow to 2,000 miles long, 500 miles wide, and 2 miles deep by the time they strike the western coast of continents. When atmospheric rivers move inland and sweep over the coastal mountains, the water vapor rises and cools to create heavy precipitation in volumes much greater than a regular storm. If the mountain elevation is high enough, precipitation comes in the form of snow. A strong atmospheric river transports an amount of water vapor roughly equivalent to 7.5 to 15 times the average flow of water as the mouth of the Mississippi River. Atmospheric rivers are a primary feature of the water cycle and tied closely to both water supply and flood risks, particularly in California. Improved satellite images, such as this one that shows the total precipitable water vapor, revealed how these storms can form far out in the remote ocean. Images such as this one allowed scientists to formally define atmospheric rivers in the early 2010s. The casual term Pineapple Express is used to describe an atmospheric river since the warm and humid air mass located in the tropic Pacific Ocean and as far as Hawaii travels non-stop until it strikes the west coast of North America. This is a clear example of how the ocean can influence the weather, specifically in California. Most of the precipitation that falls on the west coast comes from atmospheric rivers that develop in the tropical Pacific Ocean. In the strongest cases, atmospheric rivers can create major flooding when they make landfall and stall over an area. Heavy rain can also saturate the soil, leading to mudslides and debris flow following the destruction of roads. Scientists have been trying to come up with an atmospheric river intensity scale similar to the hurricane intensity scale to alert the public and the authorities of the arrival of a potentially dangerous storm. However, from late December 2022 into January 2023, a series of 9 atmospheric rivers brought a record amount of rain and snow across the western United States, hitting California particularly hard and without much warning. More than 32 trillion gallons of water rained down across the state alone. The image shows up to a 300% increase in total precipitation during the 30-day period, and as compared to the same 30-day period from 1991 to 2020. Additionally, 80% of a full seasonal snowpack was deposited in California during these storms. This image shows snowfall from December 26, 2022 to January 17, 2023. Note that the snow totals over 180 inches in the areas shaded in pink. These two satellite images show a clear difference in the snowfall accumulation between 2 consecutive years of 2022 and 2023. The parade of storms also caused significant flooding in areas of the Central Valley, Salinas Valley, and Santa Cruz Mountains, along with power outages and mudslides. This photo shows a breached levee and flooded river in Pájaro, California. I recall vividly the atmospheric river that occurred in association with a bomb cyclone on January 5, 2023. Bomb cyclones are low-pressure centers that bring clouds and rain. The difference between a regular cyclone and a bomb cyclone is the severe drop in air pressure of at least 24 millibars. This weather map shows lines of equal pressure or isobars. Notice how the pressure drops from 1016 millibars to 952 millibars at the center of the low. This gift from the National Oceanic Atmospheric Administration GOES West satellite images from January 4th, 2023 shows the arrival of the bomb cyclone associated with the atmospheric river in the central coast. Notice the counterclockwise rotation of the cyclone and the band of clouds bringing precipitation. This still image shows both phenomena, the bomb cyclone and the atmospheric river. Let's use this textbook annotated satellite image of a cyclone to learn more about the event. Cyclones rotate counterclockwise and move eastward, with the warm front arriving first, bringing light precipitation. The warm front is shown by the red line with the semicircles. The semicircles point to the direction that the warm front is moving. A short break in precipitation follows. As the cyclone continues to spin, the cold front is speeding up behind the warm front. The cold front is shown as a blue line with triangles on the weather map. The cold front typically brings heavy precipitation scattered over an area. As the cold front catches up with the warm front, an occluded front forms, and the area located under the occluded front experiences the highest amounts of precipitation. In the coupled system observed during the winter of 2023, the bomb cyclone was first felt as light rain, which is associated with its warm front. In the evening of that day, we transitioned into the cold front and felt that as isolated showers. Santa Cruz Mountains recorded around 2 inches of rain during this event. What was really significant during that storm were the high-speed winds associated with the arrival of the cold front. Gust winds of 60 miles per hour were recorded along the central coast, as you can see in this map. The quick drop in air pressure is characteristic of bomb cyclones and is what caused the high-speed winds. The high-speed winds generated 25 to 30-foot waves on the coastline. The sea cliff pier were destroyed by these high waves. In this photo, you see a section of the sea cliff pier still standing and the cement ship now isolated offshore. The cyclone also coincided with a 5.6 feet tide, which led to a greater surge and flooding of coastal areas. This image shows May Beach in Santa Cruz flooded on the morning of January 5th, 2023. These two aerial photographs show the coastal flooding that occurred in Rio Del Mar Beach, Esplanade, and coastal neighborhood. The ocean invaded the Rio Del Mar neighborhood. The high surge also caused sinkholes along coastal roadways such as Westcliff Drive. The next sequence of photos were taken during the storm and shows the Capitola Pier being destroyed. Finally, this is a photo I took of Rio Del Mar Beach in Aptos after the storm. It shows the kelp and redwood forest assorted at the beach. The sand is covered by a mix of driftwood washed down by the flooded creeks and the kelp ripped off by the powerful waves. To summarize, cyclones are generated in the North Pacific Ocean and can affect the weather in California by bringing clouds and precipitation. Bomb cyclones are a type of cyclone. They're characterized by the high and sudden drop in air pressure that can generate high-speed winds and high waves, leading to a high surge, which can cause destruction on the coast. Atmospheric rivers are another example of how the ocean can affect the weather. Atmospheric rivers form in the tropical Pacific Ocean and carry abnormally high amounts of water vapor. Once they strike the continents, heavy precipitation and flooding can be observed.